Yeah, up next is our panel discussion on decarbonization of the pipeline industry. It's a great pleasure that Dr. Peter Zeniewski will be the session chair for this discussion. Peter is lead gas analyst for the World Energy Outlook at the Paris-based International Energy Agency, IEA. He was formerly the product manager for Wood Mackenzie's European Energy Service and was a policy officer at the European Commission JRC Institute for Energy. He is a Chancellor's Fellow of Edinburgh University and holds a PhD from the University of Oxford. So, hi, Peter, and thanks for joining us today. Please, the floor is yours.
Many thanks, Dennis, and very, very many thanks for the invitation today. I'm very fortunate today to be moderating a session on the decarbonization of the pipeline industry. I'd just like to start by saying, by just giving you a little bit of background, and hopefully this complements what Barbara was saying earlier in her very impressive presentation. Earlier in May, the IEA released a report exploring a pathway to reach net zero emissions by 2050 globally. So I'd like to start by briefly sharing what happens to fossil fuels in this scenario. So the first thing to realize is that unabated coal, oil, and natural gas pretty much have to go if there's any chance of meeting ambitious climate targets in a 1.5 degree scenario. So just to illustrate the implications of that, to reach net zero by 2050, coal use would have to decline from 5 billion tons today to less than 600 million tons in 2050, and that's even with the deployment of carbon capture and storage. Oil demand wouldn't return to its 2019 peak. We'd see it decline from 88 million barrels a day today to 24 million barrels by 2050. So that's a fall of 75%. Now, natural gas is the least penalized fuel in this scenario, but that's really not much to celebrate. Demand does rebound from the dip in 2020 and rises through the mid-2020s to reach a peak of about 4.3 trillion cubic meters before dropping back down to 1.75 trillion cubic meters by 2050. So that is a 55% drop. In parallel to this drop in fuel demand, there's a massive ramp up in low emission sources of energy and a huge increase in electrification. So solar PV, wind capacity additions together are more than 1,000 gigawatts per year by 2030. Wind and solar provide 40% of electricity generation. Electric car sales rise 18-fold from 3% of sales today to about 60% of total sales by 2035. And there's also no new sales of internal combustion engine cars globally by that date. And in buildings, bans on new fossil fuel boilers come into place from 2025. And that really drives up the sales of electric heat pumps. And so most old buildings and all the new ones comply with zero carbon ready building energy codes. So there's also, in parallel to this, a huge ramp up in low carbon gases and liquids, especially for use in sectors where things are quite difficult to electrify or otherwise decarbonize. So low emissions fuels today, they account for only 1% of global final energy demand, but this share increases to 20% by 2050. And so this includes hydrogen-based fuels for ships and planes, in heavy industries like steel and chemicals, biomethane in remaining building use, and so on. And so the question here is, where does the pipeline industry fit into all of this? And that's the question of today's session, and it's a fiendishly difficult and complex subject to tackle, given all the discussions about the roles of different types of gases and liquids in the transition. So later parts of this summit will explore some of these challenges in detail, but today we'll take a broader look at the landscape and how it might affect different fuels. So the EU's ambitious targets are a backdrop to this discussion. We've seen initiatives like the Fit for 55 program, the hydrogen strategy, the methane strategy, carbon markets, taxonomies, and a strategy for energy system integration. But the fundamental point is that even though it's a byproduct, carbon is in fact a large part of what the pipeline industry transports, and infrastructure and business models have been built up around this over several decades. So the pathways to decarbonizing this industry depend, of course, on how supply and demand for gases and liquids evolve, but the industry itself can play a major role in this, essentially because it's in a unique position. There's no intrinsic preference in the industry about what type of energy is being processed and transported. It could be methane, it could be hydrogen, it could be biomethane, or any number of suffixes that exist to describe these different fuels. So I'm very pleased to have three excellent speakers to discuss the implications of all of this, each maybe offering their unique views from their respective areas of focus and expertise. We have with us today Carina Gewehr of GASCADE. Carina is a specialist in regulatory affairs with a focus on gas markets. Since the beginning of this year, she is the project lead of the AquaDuctus project, which transports green hydrogen, which will be produced offshore in the German North Sea. We also have with us today Niels Anspach, who is Vice President of Bio and Low Carbon in Customer and Products at BP Europa. And he's accountable for all things bio and low carbon activities in the midstream at a global level. And Niels will provide us with an overview of the outlook for power to liquids. And then finally, Kees van der Leun, director within the Energy, Sustainability and Infrastructure segment of Guidehouse, formerly PwC. He works with energy sector clients across Europe and the Middle East, and he's a project director in the work done in Gas for Climate, the European Hydrogen Backbone, and North Sea Wind Power Hub. So each of you now have 5 minutes to provide an opening statement for your area of focus. And I'm hoping that Carina, you could kick us off, perhaps reflect on what's already been said, and tell us about the project and how you see the industry evolving. So over to you, Carina, and thank you very much.
Yeah, thank you very much, Peter, and I hope everybody can hear me. Okay, great. So yeah, good afternoon to everybody. My name is Carina Gewehr. I work for GASCADE, which is a German gas transmission operator. And there, as you already mentioned, I'm active in the field of regulatory affairs and being at the same time the project lead of the AquaDuctus project. Before I tell you a little bit more about this, to my view, kind of exciting project, I would like to tell you a little bit what my company is doing in order to show you where, in the end, we are coming from. So, as I said, we're a natural gas transmission operator. We have a pipeline system of about 4,000 kilometers in Germany with about 30 compressor units, and we are connecting 6 European countries with our network. So we can be described as a kind of a transit natural gas transmission operator. And coming to the topic of today's panel, the decarbonization of the pipeline system, I can say as an introductory remark that this is one of the most pressing questions I guess all operators in the natural gas business are trying to answer at the moment. And of course, we as GASCADE have also been working intensively in the past years on the question how to adapt our natural gas system for the transport of hydrogen and low carbon gases. And for this, we have undertaken extensive exercises because it has to be checked how for example, hydrogen will impact the material of our pipelines and other questions. So I think this is all a topic we know as operators. And there's a big collaboration also with other gas TSOs in Europe. The Gas for Climate and European Backbone initiative shows this. We have a similar one for the German gas TSOs, where we are trying to map up a first vision of a national German hydrogen network. And this network will, mainly based on the existing natural gas system. And coming to our project AquaDuctus, I can say that GASCADE is kind of breaking new ground with this project. because it's in the end it's the first offshore hydrogen pipeline we are trying to build here. It's a project. The AquaDuctus project has 4 partners. It's GASCADE, Gasunie, RWE, and Shell. And here we are trying to implement an offshore hydrogen concept, but not as a standalone project. We are active in an initiative which is called AquaDuctus. And AquaDuctus aims at producing offshore in the German North Sea big quantities of green hydrogen. The initiative plans to produce by 2030, 2035 up to 10 gigawatts of green hydrogen in the North Sea. And we as AquaDuctus, as a pipeline project here, will have the task to transport these amounts of hydrogen to the demand centers via an offshore hydrogen pipeline. In a first step, the smaller quantities, so we will start with smaller quantities by 2026 and will then go up to 10 gigawatts by 2035. The first smaller quantities of hydrogen will be transported to the island of Helgoland. It's a German North Sea island. And later on, it's planned that the hydrogen pipeline will be connected to the German onshore hydrogen system. So this is a very exciting project, I can say. It has also a lot of challenges, but we are convinced that this is a very good solution. The alternative would be to produce renewable electricity offshore, transported via cables to the onshore, and do the electrolysis onshore. But with such big quantities, it's a more efficient and a very efficient way to do it via pipeline. So we can replace, by one hydrogen pipeline, we can replace 4 or 5 high voltage cables, which has a lot of efficiency factors in it. So this is the reason why the project decided to go this way. And as a closing remark, I would like to mention that AquaDuctus has been selected by the German Ministry of Economics as one of the 62 projects the ministry has selected for the IPCEI, so the important projects of common European interests. So we are very happy about that we are in the next round for the European matchmaking process here. And we have been selected out of over 200 other hydrogen projects in Germany, which shows that there is definitely a demand for state aid for the development of hydrogen projects. And it will be an interesting point how state aid and future investment framework will fit together, or will perhaps in the future not needed anymore with regard to the funding.
Thank you, Carina. Before we move on to Niels, I was just hoping you can answer a question on that, because what you said there about state aid is quite fascinating, and the whole project looks fascinating. I just wonder, do you have offtake contracts in place already for this project? So you said 10 gigawatts of green hydrogen by 2035. Do you already have consumers lined up to offtake that? And who are those consumers? If you can shed light on the industries that you're a part of.
Yeah, so this is a very good question because the off-takers without demand, it's a little bit complicated. To answer it, no, we haven't off-takers yet, but we are in a very big procedure also in the framework of the IPCEI, of the funding process of the German Ministry and the European Union, and there a matchmaking will take place because we have in this round also off-takers, we have pipeline operators, we have producers, and we will in the end have to figure out where the demand centers are, really when the demand will scale up. So this is already, or it's still a big discussion at the moment, but we have a lot of signals from off-takers that they will need definitely such big amounts hydrogen, especially from the steel industry. We have a lot of talks with them. No fixed contracts at the moment, but a lot of talks and elaborations.
A lot of interest. That's very good to hear. So thank you, Carina. And just moving on now to Niels Anspach. So you're working on power to liquids at BP Europa, and your activities span Germany, Netherlands, Luxembourg, Austria, Switzerland, and Poland, amongst others. So we'd like to hear about your activities in this space. So please, Niels, the floor is yours.
Yeah, thank you very much. So it's a pleasure to be here. When we look a little bit at what the direction of travel for us is, and you might have heard of that. I mean, we are on our journey as a BP from an IOC, what we call International Oil Company, to an IEC, so an integrated energy company. And I mean, this might also allude to where you are aiming at in terms of power to liquids. What are we doing there? And I think we need to look at this subject from a variety of lenses, as unfortunately there is not the one straight answer. I think especially when we look at different sectors, and maybe we come to all of this a little bit from the customer angle and where the demand is, and then we are coming to the technologies and what this might mean for the pipeline industry. So I think if we're looking forward, we have to decarbonize the different sectors. And you've already alluded to the IEA report in terms of what does it mean in terms of liquids, what is hydrogen doing, all of that stuff. I think we should also understand when we're talking about liquids, first of all, the development of modern liquid bioenergy, which is increasing. If you put that in perspective, by 2050, literally 20 to 30% of your liquid pool is bio compared to, call it, the fossil one. So this is the first answer in terms of bioenergy will play a crucial role. You can call this also power to liquid, I mean, in a certain sense, because we've just heard about hydrogen. If you do bioenergy to fuels, you need hydrogen in hydroprocessing in the refineries. For that, you ideally need green hydrogen, and for that, you need a proper pipeline connection to the assets where you're producing that. So this might be also, I mean, one of the first linkages worth mentioning. If we look at what to do where, in what kind of sector, I think we need to talk it through a little bit sector by sector. If you look at ground transportation, especially if we go to light vehicles, classic cars, and so on, I think there is a certain trend, and you mentioned that already, to electrification. And I think that is unstoppable. That will happen. At what pace? Let's wait and see. The heavy duty one is a far more complex subject with all the trucking across Europe, because potentially not in the near future, it's not foreseeable this might be batteries. So you need something liquid or gaseous to do that. Hydrogen for sure can play a certain role in heavy duty, but I think that's further down the road. Our aim is really reducing carbon intensity here and now, because every ton CO2 saved already earlier is, even more important to the climate than a ton of CO2 saved in 2050. So we need to find solutions here and now, which can be the liquid pool by increasing the amount of bioenergy in your diesel fuel. You can think about LNG, where you add biogas in whatever form, which is also a huge contributor and can be a huge contributor to the decarbonization here and now. And then the question is, how do all of these technologies relate to a future mix in 2050? If we look at the aviation industry, that has to stay liquid. You mentioned hydrogen for planes. I think this is a very, very long way down. And the clear answer from everything that we've looked at is, for the aviation industry, sustainable aviation fuel, which is literally either from renewables or waste-based, or from synthetic fuels, and a jet fuel which complies with today's specification, which the planes can use. And that's the only way in literally the next 20 to 30 years to decarbonize that sector. Because if you think about the investment needed to change the engines, all of that in the airline industry, the investment cycles are just, too long to really move there at pace. So sustainable aviation fuel will be a super important one. You can talk about power to liquid, so synthetic jet on that one, where, for example, Germany is intending to go for a certain quota. This is a very expensive way. If you look at really going at scale and in a more economic way, hydroprocessing based on renewables and waste-based to a sustainable aviation fuel is a viable route to go. Of course, there are a lot of hurdles to overcome, and also in the first generation of hydroprocessing, there might be limits in terms of availability of the feedstock and all of these things. There are other technologies further down the route in terms of really putting solid waste to fuel. That is far harder to achieve from a technology perspective. And then maybe the last two sectors, briefly, we got the marine sector, which is also either gaseous or liquid with a biogenic content. And on the petrochemical side, to be really honest, I mean, petrochemicals will be highly demanded. It has to be to a certain degree as a base component, naphtha-based. We need to make sure we are creating these kind of molecules not from fossil sources, but from renewables or synthetic or from end-of-life plastics. These are the ways to go. For whatever you talk about, from power to liquid, synthetic fuels, you need cheap renewable energy, you need hydrogen, and that I think is a bit of the equation which is linked to the pipeline industry to a certain degree, but also in the here and now, transporting the liquids, there will be higher biogenic content in the liquid pool that we are driving forward, and might be replaced over time by synthetic fuel. And maybe that's a good way to stop here, and really looking forward to getting more and more questions and get into the discussion.
Great, thank you very much, Niels. And yeah, it's a huge menu of options that you just listed there. So certainly we'll deal with those in the Q&A. But just moving straight along now to Kees. So Kees, you recently released a detailed study on the potential for hydrogen in Europe, exploring the hydrogen backbone through the Gas for Climate initiatives. So I just wondered, could you give us some key messages from the report and anything else on your mind? So you have 5 minutes, and the floor is yours. Thank you.
Yeah, thank you very much, Peter. Delighted to be here with you. My personal journey in the energy transition started 35 years ago today, actually, when I joined a startup called Ecofist, which later became part of this Guidehouse, where I'm now a director. And today I'm working on system integration issues in the energy transition towards net zero emissions. In the same 35 years, of course, the climate crisis became a lot worse. We've just 2 days ago, we saw this heat wave with 49.6 degrees in Canada, of all places. So the urgency increases all the time. And you see that reflected also in targets like Germany's recent minus 88% by 2040, which is absolutely massive. If we look at how you can get there, and other speakers have also referred to that, there's a big role for electrification. Could maybe take half or a little bit more of the final energy demand, but you also have to look at the other half and at the feedstock. And there is where we find that renewable and low carbon gases will play a big role. We've studied that indeed with the Gas for Climate group, 2 biomethane groups and 11 gas infrastructure companies from Europe, where we've also looked at the role specifically for biomethane on the one hand and for hydrogen on the other hand. And we've deepened that analysis indeed recently with the spin-off project European Hydrogen Backbone, which is now a group of 23 gas infrastructure companies from 21 countries in Europe, working together to define and start to develop a European hydrogen infrastructure. What we find there is a very important role for hydrogen in industry. Steel, of course, where you can do primary steel making with hydrogen instead of cokes and coal. Ammonia, where you need hydrogen already, and you can replace that with blue or green hydrogen. And also petrochemicals, as already referred to. We also see a very important role in the electricity system, and that's where you get into system integration, because if you have high shares of wind and solar, you will, even at the subcontinental level, you will have periods of days and weeks in Europe with too much wind and solar, and also periods of days and weeks with too little. And making green hydrogen in the first period and storing it and using it for dispatchable power in the second period can be part of the equation, of course, next to batteries and demand response and interconnection. So for all of this, you'll need infrastructure, because you can think of local applications, but yeah, you would have to be very fortunate to have a steel mill next to a giant wind farm, and an opportunity to store hydrogen. So what we see is that in the huge development towards, in our view, this 2,300 terawatt hours of hydrogen by 2050 in Europe, you will need to be able to connect sources and demand over much larger distances. And as was already introduced by Barbara, we've shown that this can be done at an affordable price, let's say 10-20 cents per kilo of hydrogen for 1,000 kilometers of transport, if you do it at scale. But we need to make that jump, of course. And just yesterday, the Dutch government announced that they'll make the first step within the country to create what they call Highway 27, to use part of the natural gas infrastructure to convert that to be able to transport hydrogen through the country and also to neighboring countries. So this is where everything comes together, because then you also see the huge development, for example, on the North Sea of offshore wind, where the countries keep announcing higher targets, and we're now at something like 80 to 100 gigawatts by 2030 already. That's just 9 years from now. By that time, you will run into these system integrations issues massively, but you'll also have the opportunity to serve the energy transition in a massive way if you manage to get all those strands together. You cannot just solve it with electricity infrastructure, because there will be windy days when you could build extra electricity transmission lines to bring electricity further into the continent, but you'll find that all of Northwest Europe is already being served. So there's no demand at the other end of the line, and you really have to think about converting it into hydrogen for later use in electricity or in other applications. And that's work that we do for the North Sea Wind Power Hub Consortium. Again, a consortium of TSOs, but in this case, a combination of electricity and gas TSOs. And I'm also happy that in this Dutch scheme, the electricity TSO is heavily involved. TenneT, also active in Germany, by the way, sees this system integration issue in much the same way as Gasunie does the gas TSO, and as we do in Gas for Climate and European Hydrogen Backbone. So very interesting developments, and starting to move from the drawing board into real life. That's it for me for the introduction.
Very interesting, Kees. Thank you very much. And certainly that's one of the key discussions here is how to sort of bridge that technology valley of death. And hopefully we can return to that now by maybe discussing a little bit the level of risk in all of this for operators and for commercial entities. So clearly, from what I hear, you're all facing a very wide landscape of possibilities and opportunities here. And some of these opportunities can coexist with others, but there's other sort of prospects for when certain technologies kind of have to win out over others, in terms of interoperability, in terms of certain blend rates, shares, equipment at the end use level, and so on. So I just wanted to pose that question to all of you: is what level of risk are you willing to bear when you go ahead and choose a project that you'd like to demonstrate at scale, or that you hope can lead to wider deployment? So maybe we'll kick that off by asking Niels, given you've given us this big overview of where liquids demand might appear and some of the options. How does a company like yours treat that level of risk internally, and how do you maybe overcome those early deployment challenges?
Yeah, I think that's a brilliant question. I think in terms of risk, we need to understand two lenses of that. The one is we need a regulatory frame that, I mean, everything that we're doing to decarbonize the world will be more expensive as what we currently do. And by that, we need a regulatory frame and a support, I mean, via a CO2 price or whatever the mechanism will be, to just support that versus how we do it today. Because, I mean, we have chosen it, how we do it today, based on the current regulatory frame, and this is the most efficient way to do it. So that's point number one. And that's honestly something where companies, as in the past as well, we need a reliable regulatory frame, and not over 2 or 3 years, and then politicians are going to change it again. But I mean, about 10, 15, 20 years, and you need to have the trust into the government and the regulator that this is being constantly supported. Otherwise, it is very, very difficult. The second is linked to that. We need a technology open-minded regulatory frame. I'm absolutely happy, and we as BP are absolutely happy to take the technology risk and make our choices which technology is the best. What we are not willing to take on is we are, based on logic, deciding and taking the entrepreneurial risk of deciding for a technology, but then the regulator is putting a policy in place which is in favor of certain technologies and in disfavor or unfavorable to other technologies. That is something where you cannot calculate on this. So that's why we always strive we need a regulatory frame that is providing the ability for CO2 reduction and making it a business case. Because without a business case, no one will do it. And secondly, it needs to be stable and technology open-minded.
Yeah, no, those are excellent points. And to be honest, if you look back at the whole energy system, there's an increasing role for governments to play in steering these technologies and valuing these externalities in a clear and predictable fashion. But I wonder, let's take the example of hydrogen, right? So there's two main production pathways at the moment. SMR with CCUS for low carbon hydrogen and green hydrogen as well. And it seems like the European Union is very much banking on green hydrogen. So perhaps, maybe Kees and then Carina, you can maybe share your thoughts about the technological determinism behind that. I mean, is this the path forward? Some people say that, based on current estimates, CCUS and SMR is the right way to kick off the industry because it's cheaper. There's already infrastructure established. Green hydrogen, there's more potential for cost reduction, but perhaps a bit more risky. So maybe share your views on some of that and how the regulatory regime might be able to navigate those two tensions. Starting with Kees, if you don't mind.
Yeah, thanks a lot. Again, a complicated part of the field. Taking the risk angle, we think that building a pipeline infrastructure can reduce risks for a lot of parties on the supply and demand side. Because if you're only dependent on your neighbor to supply you with, for example, a regular flow of hydrogen, or to take off your hydrogen from your offshore wind farm, then there's a lot of risks. If you're connected to many more sources and demand centers, then that becomes a lot less. We've also shown that the investments there are quite modest. So actually enabling this infrastructure to get converted or built can be quite a risk reducer in the whole development. Then to your blue and green question, we've also in our recent analysis looked at the potential. The technical potential for both is huge in Europe, but if you would like to get your whole 2,300 terawatt hours from domestic European green hydrogen, then you need around over 3,000 terawatt hours of additional renewable electricity on top of what you need for direct electricity demand. That's roughly a terawatt of additional wind and solar, and that's a lot. There's also there's not just physical constraints, but there's also a public acceptance issue here. Who wants a terawatt of wind and solar in their backyard?
Likewise, who wants a carbon capture and storage?
Well, yeah. So the first big project that is due to get its final investment decision in the Netherlands, and I think BP is involved there, is the Portos project, where the SMRs are already in place. They're in the Port of Rotterdam industrial area. They've been there for a long time. They serve now refineries, fertilizer manufacturers. So yeah, not exactly in my backyard, but in an area that is used to these kind of installations. North Sea is a very viable area here because you have the gas fields there. So the gas fields to get your natural gas from, and maybe from Norway as well, but also the gas fields to store your CO2. Cost levels could be around 150 €2 per kilo. Of course, we think that green hydrogen can reach that as well, maybe even go lower, but that'll take a while. So yeah, we think that the pipelines don't care. They love blue hydrogen molecules just as much as green hydrogen molecules. So again, there I think it's also risk mitigation that you have an infrastructure in place that can carry both, whatever is chosen by policymakers in the end.
Yeah, no, that's an excellent point, and leads us nicely to Carina. We're back in the North Sea, so and there's a question as well. I mean, you can also respond to what I asked earlier, but I see a question's come up in the panel here. So, what are the biggest challenges you see in developing projects like the one you're leading? And what do you think the role of the public should be? So coming back to that question of who finances this, how does it get support in this period where everyone's just waiting for costs to come down, and they think, well, why don't I wait till 2030? Why do I sign up for the expensive stuff now? So maybe you can shed a little light on that for us as well.
Yes, and when it comes to the first question, so what are the biggest challenges? I think we are right at your question you raised before, Peter. What about risks? So of course there are risks in such projects, and I can only agree with what Niels and Kees said before. In the end, we need to have a business case for to be in the position to take a final investment decision on those projects. And here we need certainties. At the moment, the legal and financial framework, so to say, is quite vague at the moment for those projects. We are, I think when we look at our funding issues at the moment, so there's really a run for public funding for H2 projects, and I think at this point in time it's really normal because demand and also production are just about to start off. So the market isn't really there at the moment, but it's beginning to develop, and therefore it's really hard to have a business case here. And this also explains the need for, at the moment, public funding, but this shouldn't be the solution for the future. So there we definitely need a stable investment frameworks and rules in place here. With regard also to this color question of hydrogen, I'm there also very much aligned with Kees, saying that we as network operators, we are kind of in a quite comfortable position. We see ourselves as neutral, so we are happy to take up green hydrogen or low carbon. So it doesn't really matter for our pipeline system. So I think this is really an advantage we have at the moment, but I can definitely see the risk for other partners in the value chain, that if the politicians decide that one commodity isn't wanted anymore, that then certain and also big risks will arise. And regarding the last question with regard to the public, I think with energy projects, it's really important and crucial to involve the public at a very, very early stage. And this is what we will do in the AquaDuctus and AquaDuctus initiative right from the start to create public awareness and support. And I think without it, it won't work.
Yeah, so lots of stakeholders in this, the public, governments as well. I'm conscious that we just have a few minutes left in the session. So what I'd like to do, I do see questions coming through, and we'll try and get those answered for you a bit later on. But just for the time being, hoping that maybe all three of you could maybe wrap things up, maybe just lending a few reflections on the future of the industry. Specifically, let's just do a thought experiment here. If you were a policymaker and you had to regulate this industry for future sort of deployment of low carbon liquids or low carbon gases, what's the one thing that you would do, the major thing that would make the most difference to the success of your industry? So, you know, I don't want to put ideas out there without hearing your responses, but, you know, would it be a carbon price? Would it be certificates of origin? Would it just be throwing subsidies? And if so, at who? So just maybe to wrap things up on that front, let's all play the policymaker and see what you come up with. So let's start with Kees, and then Niels and Carina to round us off before we close. Thank you. And just 2 minutes, or less than a minute, if you don't mind.
Success of my industry started me thinking, because that's the consulting business, right? So they better make it very complicated then. But all jokes aside, I think to kickstart these developments, you have to work on 3 sides and not one. So you have to stimulate production, for example, by setting targets on the quota for renewable and low carbon gases on the gas side, and using the CO2 price to make blue hydrogen more attractive. You have to work on the demand side, so helping the steel industry to make the jump towards using hydrogen instead of cokes and coal. And you have to provide the infrastructure, and that could well be a starting point, since it mitigates the risk. And that means maybe subsidizing first projects, but also in the end thinking about a kind of a regulated system with third-party access, like we know it from the natural gas side.
Great. That's already 3, but well done, Kees. Thank you. Over to you, Niels.
Yeah, I think a CO2 price which is uniquely applied across all the sectors in a kind of technology open-minded way, of course with the lens of sustainability, but please with the pragmatism of getting as much CO2 out of the atmosphere and out of the industry as soon as possible, being pragmatic rather than ideological.
It's great, short and sweet, and always a good answer. Carbon prices. And Carina, please.
Yeah, for me it's also nearly impossible to say that there's only one tool which should be applied to kickstart the market. But yeah, if I have to decide for one tool, perhaps I would go for the quotas.
Right.
But this wouldn't be enough.
Yeah, naturally, there's a whole suite of regulations needed for all this, but it's a great place to stop and end, and just to thank you very, very much for the lively discussion. It's been great, and I learned a lot as well about all the risks and the challenges, so I hope you did too. So this wraps up our session for today. Thanks very much, all 3 of you, and back to Dennis. Thanks again. Cheers.